Hi, I'm Anvi, and today I will be taking you through the Module 6 Magnetometer code. The code overview. The file path of the file we will be using today is File Examples, GLE 2023, Module Sketches, Module 6 Magnetometer Sensor, and then Magnetometer Basic Example. The main function of the code is to get raw data from the magnetometer, process magnetic field data and output it, and also output magnetic field magnitude. Open the code and follow along as we go. Library inclusion. When creating an Arduino sketch, it is important to include necessary libraries above the setup and loop sections. For the MLX 90395, we must include the following library, #include MLX 90395.h. This is the library for the magnetometer sensor. Object initialization. Once the libraries have been included, we must initialize a magnetometer sensor object. To do this, we will write MLX 90395 sensor underscore name in parentheses ID, false. Initialize the object with your sensor underscore name as well as a unique sensor ID given as the first argument. The second argument is whether or not the debug mode is on, which we set to false. The code described is displayed below. Variable definitions. Next, we define a variable that will be used throughout the sketch. To do this, we must write in format variable underscore type variable underscore name. In our sketch, we define one variable with the custom data type, MLX underscore sample underscore T, and we name it sample. The variable will be used to hold data retrieved from the magnetometer. It includes a variable of type sensor underscore float underscore vect underscore T called magnetic for the axes measurements. It includes a variable of type float called strength for the magnetic field magnitude and includes a variable type float called temp for the temperature sensor. And that variable definition is displayed below. The magnetometer sensor setup startup. Within the setup function, we can include code that will be executed once before the loop. In our setup function, we will start the magnetometer by calling the magnetometer.begin underscore I2C function. This will be used to turn on the magnetometer before using it to collect the data. Magnetometer sensor setup, gain and resolution. After calling magnetometer.begin underscore I2C, we call several other functions to set the gain as well as the resolution in the X, Y, and Z directions, and that is also displayed below. The magnetometer sensor setup, oversampling, and filtering. Next, we call magnetometer.set oversampling. Oversampling allows for improved resolution and signal-to-noise ratio. Finally, we call magnetometer.setFilter. The digital filter averages values over 2 to the nth measurements. Magnetometer sensor loop variable setup. Within the loop function, we include code that will be repeatedly executed. The first thing we do is take a sample of the magnetometer.getSample function, storing it in the sample variable. Magnetometer sensor loop conditional loop. The magnetic field strength and direction are calculated. Strength is calculated by square rooting the squared sum of each axis. Angle in the xy plane is calculated by using the atan2 function. Usually arctan is ambiguous as to which quadrant the angle lies in, but atan2 handles this. Magnetometer sensor loop conditional loop. Next, the magnetic field measurements for the X, Y, and Z axes are printed out, as well as the magnetic field strength. Regardless of success or failure, the process is delayed by 100 milliseconds before executing the loop again. For reference, Earth's magnetic field is around 50 microteslas. Magnetic sensor loop conditional loop. The entire loop is displayed below. I hope I've helped you understand our code a little better. Thank you.